Today we're going to talk about how to find the inverse of a quadratic and cubic function. Remember that this is what a quadratic function looks like. So first what we're going to do is create a table of values of this function and graph it. So I'm just going to choose some simple values like -2, -1, 0, 1, and 2. That'll be enough points to be able to get a good graph. So when I plug in -2 in for x, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So then I'm going to plot these points to be able to see what the graph of the quadratic is going to look like. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So this is what the parent function for a quadratic graph looks like. Our goal today, though, is to find the inverse. And to find the inverse, what you need to keep in mind is that means that the x's and y's are switched. So to find what the inverse graph looks like, I'm going to take each x and y coordinate and switch them. So this point is going to become 4, -2. This point is going to become 1, -1, 0, 0, 1, 1, and 4, 2. Now I'm going to graph these points. So I've got 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So that's what the inverse of the quadratic function looks like. The problem is our new graph is not a function. It is the inverse, but it's not a function as it is. So in order to make it a function, we need to restrict the domain, or that means like cut off a part of the graph. So I noticed that if my graph just went from 0, 0 to here, it would be a function. Remember, in order for it to be a function, it has to pass the vertical line test. For every x, there can only be one y. Or you can say it will pass the vertical line test, meaning it only touches my vertical pencil one time. So I want to not include this part of the graph, which means I am asking to restrict the domain of the original function to not include this piece right here. So I'm saying for the x's that are greater than or equal to 0 on the original function, the range for this function will be from 0 to infinity. Or I can write it, my y's are going to be everything greater than 0. On my inverse function, the x's and y's switch, and so does the domain and range. So this x is going to be greater than or equal to 0, and the range is also greater than 0. So the x's are from 0 to infinity, and the y's also begin at 0 and will go up to infinity. Okay, now let's take a minute and look at the cubic function. The cubic function is x cubed, and so if I plug in each of these x values, these are the y values I will get. For example, -2 cubed. Remember that -2 cubed means -2 times -2 times -2, which equals -8. When I plug in -1 cubed, I get -1, and so on. Then we can plot those points on our graph and we get our cubic function. Remember, our goal today, though, is to find the inverse of the cubic function. So in order to find the inverse, again, we're going to switch our x and y coordinates. So this is going to become -8, -2. This one's going to become -1, -1, 0, 0, 1, 1, and 8, 2. So now I'm going to plot these so we can see what the inverse graph looks like. So -8, -2, -1, 1, 0, 0, 1, 1, and 8, 2. It's going to be about right there. So that is what the inverse graph is going to look like. Remember that the inverse for any function that we do will always reflect across the line y equals x. That means if I was going to fold my paper across this diagonal line, the graphs should exactly match up. And if they do, that is one way to prove that they are inverses of one another. And if we folded it, we would see that this little black squiggle would line up with that blue inverse function graph. For the cubic function, we don't need to restrict the domain at all, because if you notice, even the inverse passes the vertical line test. For every x input, there is only one y output. So our domain and range for both the original function and the inverse function, the domain is all real numbers, or you can write it from negative infinity to positive infinity. The range is also all real numbers, or you could write it negative infinity to positive infinity. So that's what a cubic function looks like. And as we graph the cubic function inverse, the name of that cubic function inverse is the cube root function. So far we have learned how to find the inverse from a table by switching x and y. We found it from a graph by reflecting across the line y equals x. And the third way to find an inverse is algebraically. Now, finding it algebraically, you start with the same step. You're going to flip the x and y. So if I'm given a function like this and I want to find the inverse, I want to first switch the x and y. Keep in mind that f of x means the same as y. So I'm going to rewrite this as x equals y squared minus 7. After you switch x and y, then you want to do the algebra to get y isolated. Get it by itself. So I am first going to add 7 to both sides. So you have x plus 7 equals y squared. And then to get rid of a square, to undo a square, you would take the square root. What I do to one side, I have to do to the other side of the equation. So the square root of x plus 7. The final step is to write it with that little negative 1. That means it's the inverse of the function is the square root of x plus 7. Now, one thing to note is that this domain is going to have to be restricted, because in order for this to be a function, x is going to have to be greater than or equal to 7, negative 7. The reason why is if this is smaller, if this is like negative 8, negative 8 plus 7 is going to be negative 1. Remember, we can't take the square root of negative 1. So that's why it's very important to note that our domain is going to be restricted to all values that are greater than or equal to negative 7. Okay, this time we're going to find the inverse of a cubic function. So again, we're going to do the same process. First begin by switching x and y. So I'm going to rewrite this as x equals y minus 2 cubed plus 4. Now I'm going to do the algebra to get y isolated. So I'm going to begin by subtracting 4 from both sides. X minus 4 is y minus 2 cubed. I can't add the 2 next because it is trapped inside these parentheses. So I next need to get rid of this cube. The opposite of cube is cube root. So I'm going to take the cube root, that little 3 notes that it's the cube root. And then this cube root is going to cancel the cube, so I'm just left with y minus 2 equals the cube root of x minus 4. Last thing I need to get rid of is this minus 2, so I'm going to add 2. Be careful, I cannot add this 2 to this minus 4. It is underneath this cube root. A lot of students try to add these together, but I cannot do that. All I'm going to have to do is bring down the cube root of x minus 4. The plus 2 is outside of the radical. And I'm going to finish off by writing it with the f of negative 1 because that's indicating that I found the inverse of this function. There's one last thing I want to show you. Whenever we have inverses, we can prove that two functions are inverses of each other by using what's called composition of functions. That means taking the original function and putting it into the inverse to see if they equal out to just be x. So that's what I'm going to show you now. First thing to prove it is you should be able to prove that you can input f of x into the inverse and the inverse into this function. What that looks like is first I'm going to take f of x and I'm going to input the inverse. So I'm going to take the inverse function, which is this, and I'm going to input it for x in the original function. So what that's going to look like is square root of x plus 7, that's what I just put in place of x, and it's squared minus 7. Now I'm going to simplify it down. Notice when you square a square root, they cancel each other out. So I am left with x plus 7 and then bring down the minus 7. Well, 7 minus 7 is 0. So it equals x. If it equals x, which is what our input was, then you have proven that they are inverses of each other. Now let's try doing it the other way. What happens if I take the inverse function? I'm going to take the inverse function and plug the original function inside of it. So I'm going to take this function, the original one, and I'm going to put it inside of x in the inverse function. So I'm going to take, instead of this x, I'm going to write x squared minus 7, and then I'm going to pick up with the rest of my function right here is plus 7. Then again, I'm going to simplify it down. Well, right here, I don't have anything to distribute, so I don't really need those parentheses anymore. Negative 7 plus 7 is 0. So I'm left with the square root of x squared. Well, the square root cancels out that x squared, and again, I'm just left with x. So by plugging the functions into each other, I have now proven that the functions are actually inverses using composition and functions. So that's the bulk of what we're going to learn for finding the inverse of quadratic and cubic functions.